Each of the thousands of different proteins in nature is actually a chain made from a specific combination of 20 different amino acids. The sequential order of these chemical building blocks is crucial, for if they are arranged correctly, the chain folds into a functioning three-dimensional molecule. But if the amino acids are incorrectly assembled, no protein will form. If proteins are indeed rare among the possible sequences of amino acids, what are the odds that mutations would stumble upon a functional combination of chemicals from the vast number of alternatives? To find out, Axe randomly altered the structure of an enzyme protein comprised of 150 amino acids.
You've got a protein 150 amino acids long, then you've got 20 to the 150th power possible ways of arranging the amino acids. Out of all those possibilities, how many are functional and how many are gibberish?
If you do the experiments and you analyze how much information is required to get, say, a new protein fold, it's just far beyond what you can get by random mutation and natural selection.
How far beyond? Axe published his findings in the Journal of Molecular Biology. He determined that among all the possible amino acid combinations, the probability of generating just one short protein by mutation is roughly 1 in 10 to the 74th power, or 1 chance in 100 trillion, 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 trillion.
To put that in context, there's only 10 to the 65 atoms in the entire galaxy. So to build a new functional protein by selection and mutation within the time allowed for the Cambrian explosion, what you're essentially having to do is equivalent to a blindfolded man looking throughout the entire galaxy for one marked atom. So what we're talking about is searching for a tiny, tiny needle in an enormous haystack and having a very limited time to search.
So on the question of something like the Cambrian explosion, there does not appear to be any way that unguided random mutations can accomplish what needs to be accomplished to explain new functional proteins. And certainly by extension, wherever in the history of life you would need to have multiple new protein folds, the probabilities multiply. So there's no reason to think that this is plausible.